In the previous video on threats and countermeasures, we explained how we can actually specify that certain tokens, like these ones in the top left here, are defined as threats, and the state where they're defined on will get a red outline, and then some transitions in the network will be defined as countermeasures. You can see two of them here, and you can see that the threats and countermeasures are tied up. So this countermeasure repair network here is tied to the network auth, which we can find up over here. And of course we can see the state containing network auth is also mentions which countermeasure it's tied to, or recovery as we call it in the code. So in this video I want to show you the validation options for this. In the previous video we showed that these do have to be tied together for this network to load, but now we have some additional options where it can also double check at runtime that a specific threat is recovered by the stated countermeasure or the stated repair. Let's have a look at the code for that. Here is the code that we use to define that particular contingency plan. And you see at the top here, we define a threat, and down in the contingency plan, we specify that a particular repair is tied to that threat. And this can also be described in a separate line if we want, like this. Recovery. We can say that repair network or recover network auth. So that can also be done. This is particularly useful if you load contingency plans from files and reuse them. You don't want to specify the recovery in the file because it will be different depending on what scenario you're loading. But for simplicity, let's leave this one alone. Keep it like this. And see what happens if we make a mistake. For example, we tie this recovery to the wrong threat. See, I've put in a X in the threat name, so it will not line up with the actual threat at the top. Let's reload this. And we see we get an error message at the top here. It says it has failed to load the scenario because it cannot find a matching threat. Network auth X. And that is correct. There's no matching threat X. So we'll fix that. Load this again. We'll see. Everything's now fine. So let's run this before I show you the runtime validation. This time it should work. We've connected this up correctly. So you see these threads running through here. Disk failure, and of course these all end up at the end. And when it's finished we should get notification. There we go. Scenario finished at 55 time units. The threat network auth was recovered by the repair network, and it tells you the path that it followed. This information is not held for very long, but if you just try to run it again, you'll get the final report back again, because we are at the end. So just click the start button and you'll get the report directly. You can see the entire path that it took for that particular one. The threat server stopped was recovered by repair server, and you can see. So there's a difference. There was a fail network access and here was a pass network access. It went to repair network and repair server. Right. Click reset, we get it back to the beginning again. And then if you click start, of course, it runs through. Alright, let's make a mistake in our contingency plan that will cause a certain threat to be recovered by the wrong recovery. If you look over here, we did make a key decision here at network access, saying that we want threats involving network to be recovered by the repair network and anything else recovered by repair server. Let's make a mistake in this so that we don't get anything repaired by the repair network, and instead it gets repaired by this catch-all repair server. That would be here in this network. Let's make a mistake in that. Network X. Let's reload this. And now we'll see that when the network threat comes down here, it will not get sent to the repair network, it will get sent to the repair server because it no longer matches this. Let's start the simulation and watch that happen. Got sent to repair server and repaired. Well, now we get an error up here. So even though the repairs worked, because we've got a very general purpose repair statement here that will repair anything, it was found to be invalid because this threat, network off, did not pass the expected recovery, and then it tells you the path that this followed. So you can see which was the wrong path that it took. Now of course this is a slightly contrived example, but it's quite easy. If we were more careful, we'd make sure that the repairs only worked on the correct tokens. Then of course you could end up in an infinite loop because it would simply never repair anything, and that you would observe as well. But in this case, our general purpose repair has been found to be faulty because it got sent the wrong route. And this is a runtime check on the contingency plan.